Okay, so here is a picture of what the ocean would look like if you were to drain out all of the water. So there's the ocean basins. And in a previous lecture, we've actually already discussed all of these major features that you're going to find on the ocean floor. So some of this is going to be a summary, and then there's other parts that we need to talk about in more detail. So it all goes back to plate tectonics. So in plate tectonics, plates could be pulled apart. And if that is occurring in oceanic lithosphere, then that's what creates new ocean floor. And so that's going to make mid-ocean ridges. And so what it's going to look like from the side view is that you're going to have the ocean floor coming up like this, and then it's got some down like this, and then here is where stuff from the asthenosphere is coming up, and then it's making new ocean floor. So this is going to make mid-ocean ridges, and you can see that there's one that goes down the middle of the Atlantic Ocean, and then there's another one off the coast of South America, and they kind of wrap around the earth like the seams of a baseball. So later we'll talk about just how tall these structures can be, but that's a mid-ocean ridge. Okay, and that was where plates were being pulled apart, so that was a divergent zone. Then you could also have places where two ocean plates were being pushed together, and then that was going to be called convergence. And so if they're being pushed together, then what we found was that one of the plates would go underneath the other ocean plate. So whichever one is the colder plate, it's going to be the one that's the more dense, and it's the one that's actually going to go underneath the other oceanic plate. And then this is going to make trenches. And so in this picture over here, you will see that there's a whole bunch of trenches located in the western Pacific. And so the deepest trenches in the world, like the Marianas Trench, are located over there. Okay, then you could also have a situation in which an ocean plate was hitting a continental plate, and again, the ocean plate is going to go underneath the continental plate, and then when it melts, the lighter materials are going to come to the surface, and so we're going to get volcanic mountains there. And I also forgot to mention here that you're going to get volcanic islands. So for an example of this would be the islands of Japan, whereas the volcanic mountains, an example of that would be like Mount St. Helens, Mount Rainier. The Andes Mountains are a result of subduction. And so are the Rockies, but the Rockies are going to be older. So, and then there's also, you'll notice that there's some stuff in the middle of the oceanic plate, so some islands. So we have chains of islands as a result of hot spots. Well, we've already seen this picture, but I also wanted to show you this one, which is a colorized version of it, and it shows where the deepest parts of the oceans are located at, and then that's going to be that dark blue. And then the greenish areas are going to be areas that are going to be shallower. So I thought that this was kind of interesting because this one gives you a better idea for how deep the oceans are. Okay, so now let's talk about what does the ocean floor look like, and we're going to start with the continental margins. So over here, let's put it over here. We're going to start with a continent, okay, and then it's going to go on to the ocean floor. So the continental shelf is going to be an extension of the continent. The continental shelf is underwater, okay, so let's say that right here is where the level of the ocean is located at. So right here, this would be the continental shelf, and notice it's very shallow. It's only 130 meters deep, and also notice it's extremely flat. So the slope of the continental shelf is only 0.1 degrees, and so that's very small. It's flatter than Kansas, okay, right here on the continental shelf. So this is basically where the ocean has sloshed up onto the continents. Okay, then you've got the continental slope, okay, and so that marks the boundary of the continental lithosphere. So that actually what you have here is, here's the continental lithosphere, and then over here is the oceanic lithosphere, and then where it's dropping off, that's the edge of the continent, and so that's the continental slope. And notice it has a slope of about 3 degrees, which you might not think that that's very much, because if you take a protractor and you make an angle of 3 degrees, well, that's not very much. But in terms of the continents, that is significant. And notice that the depth to the continental slope is about 2,000 meters. Okay, then you've got the continental rise, which is going to be this part right here. And so that is mainly debris that is coming off the continent. So as erosion occurs, stuff flows down the continental slope, and it accumulates on the continental rise. And it goes down to about 4,200 meters and has a slope of 0.4 degrees. So notice again, it's very, very flat. But that picture there is greatly exaggerated as to the angles that are involved. Okay, so what happens next? So once we get off the continental margins, then the next part of the ocean is going to be the basins. And so you're going to have the abyssal plains, which is going to be the bottom of the ocean floor, excluding the trenches, and it's going to be about 4,500 meters deep. So that's about 4.5 kilometers down. So it's extremely deep. This is approximately where the Titanic is located at. And notice it is very flat, so 0.3 degrees is the slope down there. Okay, then you also have abyssal hills. So if we were to just put a couple of hills on here, so they're on the floor of the abyssal plains. They're less than 1,000 meters high. They could be volcanoes that are covered up with sediment, or they could also be places where the ground has been pushed up by faulting, and then sediment is covering that fault. So that's what those things are. Okay, then you've got your ridges and your rises. So we already talked about this. So if we continue this over here, then we're going to have places where this is where the ground is fractured as it's being pulled apart. Okay, so that's a mid-ocean ridges. When you approach, this is the ridge, and then as you're approaching the ridge, this would be the rise. So over here is the rise. In the same way that you have a rise over here, you have a rise over here as it approaches the mid-ocean ridges. And the ridges are about 2,000 meters high. So that's about roughly speaking, about 6,000 feet. So that's roughly a mile. So the distance from here up to here is about 1 mile. But remember that the depth of the ocean is 4,500 meters deep. So that means that there's still 2,500 meters of water on top of this. So that's the reason why you normally don't see those mid-ocean ridges. Then you got the trenches. So let's go ahead and put one of those things in here. Now this, if this is North America, this is the mid-ocean ridge in the middle of the Atlantic. And then I'm just going to put a trench over here. There really is no trench, but just for the purposes of being able to draw one. So this is going to be where a plate is then going down, and then you could have something like that. And so there's your trench. The trenches are 6,000 to 8,000 meters deep, And so that means if you take Mount Everest and put it inside one of these trenches, it would not be sticking up out of the water. So it is so deep on these things. And then notice it is pretty steep, 3.4 degrees. So this steepness right here is equivalent to this steepness over here as you're coming off the continents. But again, this is greatly exaggerated. Okay, then another feature is the faults. So that if we go back to this picture here, shows it best, the mid-ocean ridges kind of look like this. And so here is faulting as a result of the stretching of the crust. And so I found, actually a student gave me this picture, and it kind of shows all of these different kinds of features. It also shows the deepest parts on the continent. So it shows like Death Valley, for example, is on there, and it's very, very small in comparison to those trenches. So it's just something that you can look at there, and gives you an idea for how tall are these ridges, how deep is the ocean, how deep are the trenches. Some other volcanic features are going to be reefs, atolls, and guyos. And so what happens in how a atoll forms is you first start with a volcano. So here is our volcano, and it's out in the middle of an ocean somewhere. And then what happens is, so let's say that this is the current level of the ocean. Well, reefs are going to start to form right here because they have to have some substance in order to anchor onto. So they're going to start to grow right next to that volcano. Okay, but what can happen though is that as the volcano begins to die, it then begins to be worn away by erosion, so that eventually this volcano might only be about this big. Well, now this reef that is out here, it continues to grow, and so it's going to make a ring that encircles this dead volcano, and that's going to be an atoll. Okay, and then what can finally happen is that the volcano can be completely gone, and all that you have is a fringing reef of coral that represents where the volcano used to be located at. Okay, and then a guyot is going to be a volcano that has been sheared off. So these things then can go under the water because the further away the plate goes from its source of heat, the colder that plate's going to get. And the colder the plate gets, the more dense it's going to get, and so it's going to start to sink into the ocean. And so what you can have is volcanoes or remnants of volcanoes on the bottom of the ocean floor, and those volcanoes are not active today, and then those things are going to be called seamounts. Okay, another volcanic feature is an oceanic plateau. So remember that the kind of rock that makes up the ocean floor is going to be basalt and gabbro. So in the first picture there, it shows a blob of magma coming up from the asthenosphere, and then it's going to hit a lithospheric plate. So as it's coming up, it's going to hit that plate, and it's going to start to melt it, and then debris from that melt is then going to make its way up to the surface and is going to erupt as gigantic basaltic lava flows. And so these lava flows can be huge. So they can be the size of the state of Missouri here in North America. Just huge flat areas composed of basalt. And so those are going to be called oceanic plateaus. All right, let's take a break. When we come back, we're going to talk about the sediments found on the ocean floor.